Welcome to the introduction class for computer vision. So, computer vision is an essential field of AI that enables machines to interpret and understand visual information such as images and videos, much like humans do. The main goal of computer vision is to make sense of digital images in the same way our brains do, allowing machines to process, analyze, and act based on visual data. This includes development of algorithms and models that can recognize patterns, detect objects, track movement, and even generate images, all while improving through experience. Over the year, the computer vision has evolved into one of the most impactful areas of AI, with applications ranging from healthcare to entertainment, significantly influencing industries' technology. In essence, computer vision involves a blend of image processing, machine learning, and deep learning techniques to achieve this. It is closely connected to fields like pattern recognition, robotics, and machine perception, with the key focus being on providing the systems with the ability to see and understand what is happening within the visual world. Over time, computer vision has become integral to fields such as autonomous vehicles, security systems, and augmented reality, transforming the way we interact with machines in daily life. So, the power of computer vision has unlocked a wide range of innovative applications across industries, enhancing existing processes, improving efficiency, and enabling entirely new technologies. Some notable applications include healthcare. Computer vision plays a crucial role in medical imaging and diagnostics, enabling disease detection and assisting medical professionals in identifying abnormalities that may not be immediately obvious to the human eye. For example, tumor detection, MRI scans, or cell segmentations in pathology slides can be made more accurate and efficient using computer vision models. Furthermore, computer vision can automate the process of analyzing radiology images, helping doctors detect early signs of conditions of cancer, such as cancer, fractures, or heart disease. Autonomous vehicles or self driving cars rely heavily on computer vision for their functionality. The system uses vision algorithms to recognize objects in their environment, such as pedestrians, other vehicles, road signs, traffic lights, and obstacles. Through object detection and scene understanding, computer vision enables vehicles to navigate complex environments safely. Computer vision is also used in driver assistant technologies such as automatic lane keeping and collision avoidance systems, enhancing road safety. So, in the field of surveillance and security, computer vision is used to implement facial recognition systems for real time identification and monitoring. These systems can identify individuals from a video stream or image, enabling automatic identification at access points such as airports, banks, and smartphones. Moreover, it's applied to anomaly detection for identifying unusual activities or intruders in security footage. So, in the retail industry, computer vision is revolutionizing how businesses interact with customers and managing operations. Automated checkout systems, which use cameras and machine learning algorithms to scan products without the need for barcodes, are becoming increasingly common. Additionally, computer vision helps with inventory managing by enabling real time tracking of stock levels and product movement on store shelves, improving inventory control and supply chain logistics. AR and VR are two rapidly growing areas that rely heavily on computer vision. In AR, computer vision enables devices like smartphones and AR glasses to overlay digital content onto the real world, creating immersive experiences. In VR, computer vision is used for motion tracking, creating realistic and interactive environments. Computer vision is also used in video games for facial and gesture recognition, enabling more immersive and interactive gaming experiences. So, to dive deeper into how computer vision works, it's essential to understand the basic concepts that form the foundation of the field. These concepts are core to developing successful computer vision algorithms and systems. So, image classification is one of the most fundamental tasks in computer vision. It involves training a model to assign a label to an entire image. The model typically learns to recognize patterns and features in this image to predict what the image represents. For example, a model trained to recognize pictures of animals may classify an image as a cat, dog, or elephant based on the features detected in the image. Advanced deep learning techniques like neural networks, CNNs, are often used for this task due to their ability to learn hierarchical features in images. Object detection is a more complex task where the system not only classifies the object within an image but also localizes them. Localization involves drawing bounding boxes around the objects to identify their exact position within the image. Object detection algorithms are widely used in applications like self driving cars where the system needs to detect pedestrians, other vehicles, road signs, and obstacles in real time. For example, YOLO, you only look once, and RCNN or region based convolutional networks are popular models for this task. Segmentation goes beyond classification and detection by dividing an image into smaller, meaningful parts. It involves breaking an image into different regions or segments, which can then be analyzed separately. For example, semantic segmentation assigns a label to each pixel on an image, identifying which part belongs to an object and which part is background. This is used in medical imaging, where distinguishing between tissues or organs is essential for diagnosis. Feature extraction involves identifying important patterns or characteristics in an image that can be used for further analysis. Features like edges, corners, and textures are extracted and then used to recognize objects or perform other tasks like image stitching or tracking. Feature extraction is a critical step in many computer vision applications as it enables the system to focus on the most relevant aspects of an image. So, as mentioned, image classification involves labeling images based on their contents. So, here's a detailed process that is typically followed. So, data collection. The first step is to gather a large and diverse data set of images that are labeled according to their contents. These images serve as the training data for the model. For instance, in an image classification task for cats and dogs, the dataset will contain labeled images of cats and dogs. Pre-processing. In this stage, the images undergo a series of transformations to ensure they are suitable for analysis. Pre-processing tasks might include resizing the images to a standard size, normalizing the pixel values to a common scale, or performing data augmentation to artificially increase the size of the training dataset by applying random rotations of flipping or zooming to the images. Model training. The prepared dataset is used to train a machine learning model such as convolutional neural network. CNNs are particularly effective for image classification tasks due to their ability to learn spatial hierarchies of features in images. During training, the model adjusts its internal parameters based on the images it processes to minimize the difference between its prediction and the actual labels. After training, the model's performance is assessed using evaluation metrics such as accuracy, precision, recall, and F1 score. The model is tested on a separate dataset called a validation or test set that it hasn't seen during training, and these metrics help determine how well the model regeneralizes to new data. Object detection involves not just classifying objects in images, but also identifying where each object is located within the image. Here's how the process works. So the sliding window is an early technique used in object detection where a small window of fixed size slides across the image. At each position, a classifier is applied to detect objects. So region-based convolutional networks, or RCNNs, are a more advanced approach where region proposal network generates potential greater regions and a CNN extracts features from these regions to classify objects. YOLO, or You Only Look Once, is a real-time object detection system that processes the entire image in one go, predicting the class and bounding boxes for all objects in the image simultaneously. YOLO is extremely fast and widely used in applications that require real-time detection, such as self-driving cars or security cameras. So here's an example of how image classification works using a convolutional neural network. So the convolutional neural network, the first layer, the convolutional layer, applies a set of filters or kernels to the input image. These filters are responsible for detecting specific features such as edges, corners, and textures. After the convolutional layer, the pooling layer reduces the spatial dimensions of the feature maps while retaining the most critical information. This makes the network more efficient and helps prevent overfitting. After pooling, the feature maps are flattened and fed into a fully connected layer. This layer is similar to a traditional neural network and is responsible for making the final classification decision. Finally, the output layer produces the classification results, typically using a softmax function to assign probabilities to each class, such as cat or dog. This section provided an in-depth introduction to computer vision, discussing its applications, basic concepts, techniques, and algorithms used in image classification and object detection. From healthcare to automotive and entertainment, computer vision is transforming the way we interact with technology. Understanding these foundational principles is crucial for leveraging the full potential of computer vision and enabling machines to see the world in a meaningful way. As the field continues to evolve, new advancements in deep learning and neural networks will open up even more exciting possibilities. Catch you next.